Alright, so let's continue on with problem 34 in KC9. Target C. 34. Write an exponential function to model a population of 3,056 wolves growing at a rate of 2.1% per year for 8 years. Since we have a rate per year, this represents the formula A parentheses 1 plus R raised to the T. So we just need to write the equation. So we have, I'm going to write P of T for population over time is equal to my initial, which was 3,056 wolves, times 1 plus my rate, 2.1, make that into a decimal, which will be 0.021, raised to my T. We want 8 years. Okay. Then we have, that will be P of T is equal to 3,056 times 1.021 raised to the 8. And that'll be it. S 35. Solve the following equation. We have the cube root of 2x plus a is equal to 4. Since the radical is already by itself, we have to get rid of it. To get rid of it, we always raise it by the index. The index here is 3, so we raise both sides by 3. The index gets cancelled, leaving you with 2x plus 8 is equal to 4 cubed. So we have 2x plus 8 is equal to 64. Subtract 8 to both sides, leaves us with 56. Divide by 2 is with x equals 28. Then from here we have to check the work. So we do the cube root. We substitute 28 in for x. So we have the cube root of 2 times 28 plus 8 is equal to, well, I know the cube root of 2 times 28, well, better yet, we'll just show more work. That'll be 56 plus 8. This will be the cube root of 64. The cube root of 64 is 4. And as you can see here, since they match both sides, 28 is the solution. If they did not match, it would have been the extraneous. 36. We need to get the radical by itself. We have 7, so we need to subtract 7 on both sides. Even with the square root of x plus 4 is equal to negative 5. Then, whenever the index is blank, that means the index has to be 2. So to get rid of the 2, we have to square both sides. By squaring, it gets cancelled, leaving you with x plus 4 is equal to 25. Negative 5 times negative 5 leads to a positive 25. And then solve for x. X is equal to 21. After that, we have to check my work. So we do the square root of 21 plus 4 plus 7. Our goal is for it to equal positive 2. 21 plus 4 is 25 plus 7. This turns out to be 5 plus 7. 5 plus 7 is equal to 12. As you see here, it does not. 12 does not equal 2. Therefore, 21 is an extraneous. Since 21 was my only possible solution and it turned out to be extraneous, that means I have no solutions. $37. We need to solve for x, given 3x plus 7 raised to the 1/3 is equal to 5. This one's very similar to the previous problems. Here, we need to make the exponent 1. So what number do we need to multiply 1/3 to equal 1? So it's 1/3 times x is equal to 1. X has to equal 3. In order to make 1/3, in order to multiply by 3, we cannot just multiply by 3. We need to raise both sides by 3. When we have an exponent raised to an exponent, that leads to multiplying the exponents. So we have 3x plus 7 raised to the 1/3 times 3 is equal to 5 cubed. The 1/3 and the 3 will cancel, leaving me with 3x plus 7 is equal to 125. Add 7 of both, subtract 7 of both sides. So 3x is equal to 118. Divide both sides, so x is equal to 118 over 3. Then from there, we need to substitute it back in. 3 times 118 over 3 plus 7 raised to the 1/3. Type this into your calculator. The 3's will cancel, leaving you with 118 plus 7 raised to the 1/3. That results to 125 raised to the 1/3. By the way, I'm just me checking work. When we have a fraction as an exponent, I'm going to convert that to radical form, resulting in the index being the denominator of 125. The numerator is the exponent inside the base. The cube root of 125 is 5. As you can see here, since they match, that means x is equal to 118 over 3. And that completes KC9.